Hello, future fifth graders, and welcome to today's subtraction of whole numbers lesson. We are going to talk about subtracting whole numbers with regrouping. Regrouping means to rearrange groups of tens in order to subtract. Let's begin our lesson on subtracting whole numbers with a review of a few vocabulary words related to subtraction. First, let's review what subtraction means. Subtraction is the process of finding the difference between two numbers. There are four parts to a subtraction problem: the minuend, the subtrahend, the difference, and the subtraction sign. The minuend is the amount we begin with in a subtraction problem. The subtrahend is the amount we take away from the minuend. The difference is the amount that is left after we subtract two numbers. Now let's talk about regrouping in a subtraction problem. Regrouping means to move groups of tens from a larger place value to a smaller place value to allow us to subtract. We must regroup when a digit in the minuend is smaller than a digit in the same place value in the subtrahend. For example, in the problem 397 minus 158, regrouping is needed in the ones place because the 7 is smaller than the 8 in that same place value. We cannot subtract 8 things from 7 things. That means we must regroup from the tens place to the ones place to increase the number of ones. In this problem, regrouping is needed in only one place value, the ones place. Regrouping may be needed in one or more than one place value. We will discuss how to regroup from the tens place to the ones place in this problem in the next few moments. To show you how to add more ones to the 7 ones in 397, we will first represent 397 with base 10 blocks, 3 hundreds, 9 tens, and 7 ones. We will move the blocks to show the regrouping process from tens to ones. We will also record this regrouping process in the subtraction problem as we move the blocks. Look at the blocks in our base 10 model. Pause the video and count the tens blocks you see. To increase the 7 ones in 397, we need to take one 10 block from the 9 tens blocks in 397 and trade it for 10 ones blocks. Notice we drew a line through one tens block and added 10 ones blocks in the red circle to the 7 ones blocks that were already there. This is step 1 in the process of regrouping tens to ones in this problem. Let's look again at the blocks in our base 10 model. After trading the 10 for 10 ones, we now have 3 hundreds blocks, 8 tens blocks, and 17 ones blocks. When we removed that one 10 from the 9 tens, it left us with 8 tens blocks and 8 tens in the tens place in 397. In other words, 9 tens minus 1 10 equals 8 tens. Pause the video and count the tens blocks. Remember, this is the first step in the regrouping process in this subtraction problem, and now we need to record this step. Look at the subtraction problem. To record the 8 tens, we first draw a line through the 9 in 397. Then we write an 8 above the 9 in the tens place to record that we now have 8 tens. Remember, we have 10 ones blocks for that 10 we removed. We can see that there are now 17 ones blocks in our base 10 model. Pause the video and count the ones blocks. Remember also that we needed to use those 10 ones to increase the 7 ones we already had in 397. This is step 2 in the regrouping process in this problem. So we will add those 10 ones to the 7 ones in 397. And 10 plus 7 gives us 17 ones. Now we must record the 17 ones in 397. Look at the subtraction problem. To record the 17 ones we now have, we first draw a line through the 7 in 397. Then we record a 17 above it. So instead of 9 tens and 7 ones, we now have 8 tens and 17 ones, which is the same amount, just written differently. Now look at the digits in the ones place in both numbers in the subtraction problem. Did regrouping give us more ones in 397 to be able to subtract the ones in 158? If you said yes, regrouping gave us more ones, so we can now subtract in the ones place. You are absolutely correct. Now we can subtract 8 ones from the 17 ones in 397. Let's remove 8 of the 17 ones blocks in the model. Notice we drew a line through the 8 ones blocks. This represents 17 minus 8 in the subtraction problem. How many ones blocks are left in the model when we take 8 blocks away? Pause the video and count them. So 17 minus 8 equals 9. Look at this subtraction problem. To record the number of ones that are left in the subtraction problem, we will write a 9 in the ones place at the bottom of the ones column. Now we need to subtract in the tens place. To do that, we must first decide if we need to regroup from the hundreds place to the tens place in 397. So let's look at how many tens are in both numbers. Look again at the subtraction problem. How many tens are in 397 now? If you said there are now 8 tens in 397, you are correct. How many tens are in 158? If you said there are 5 tens in 158, you are correct. Now, think about this. Do we have enough tens to subtract 8 minus 5, or do we need to regroup again? In other words, do we need more tens to subtract 8 tens minus 5 tens, or do we have enough? I hope you said that we have enough tens because 8 is bigger than 5 in the tens place. So we do not need to regroup here. We just need to subtract the tens as they are. We will first remove 5 tens blocks from 8 tens blocks in our model by drawing a line through 5 of our tens blocks. Look at the tens blocks in the model. How many tens blocks do we have left in the model? If you said 3 tens are left, you are correct. Look at the subtraction problem. Since we have 3 tens left in the model, and 8 minus 5 is 3, we recorded 3 in the tens place at the bottom of the tens column. Now we need to subtract in the hundreds place. Let's look at the digits in the hundreds place in both numbers in the subtraction problem. There are 300s in 397 and 100 in 158. So do we need to regroup the hundreds? If you said no, we do not need to regroup the hundreds, you are right. That's because 300s in 397 is bigger than 100 in 158. We simply remove 100 block from 300s blocks in our model with a red line. Once the 100 block is removed, we can see that we have 200 blocks left in our model. Look again at the subtraction problem. We recorded 2 in the hundreds place at the bottom of the hundreds column because 300s minus 100 equals 200s. Let's review what we did. Notice that we regrouped only once in this subtraction problem, from the tens to the ones. We traded 1 10 for 10 ones, so that we subtracted 8 tens and 17 ones instead of 9 tens and 7 ones. Our difference, meaning our answer to the subtraction problem, is 239. Let's look at another example where we regroup once, but this time we will regroup from the hundreds to the tens. It is important to say that when we subtract, we always start by looking at the ones place to decide if we need to regroup a 10 for 10 ones. Why do you think we start with the ones place? Pause the video and turn and talk with a partner. If you said it is in case we have to regroup from the tens to the ones place to get more ones, you are correct. In subtraction, we cannot trade a 1 to get 10 tens, but we can trade a 10 to get 10 ones. Notice the digit in the ones place in 728 is 8. Notice the digit in the ones place in 564 is 4. Do we need more ones to subtract 4 ones from 8 ones? If you said no, we do not need more ones, you are correct. Since we don't need more ones, we know we can subtract the ones without regrouping a 10. So we will cross out 4 ones blocks from the 8 ones blocks in the model. How many ones blocks are left? If you said 4 ones are left, you are correct. So 8 minus 4 is 4, and we record the 4 ones that are left in the subtraction problem at the bottom of the ones column. Since the next place value we subtract is tens, look at the digits in the tens place in 728 and in 564. Can we subtract 6 tens from 2 tens? If you said no, we cannot do that, you are correct. So in order to subtract the tens, we need to increase our 2 tens in 728 somehow. Consider this question. How can we get more tens in the tens place? Here's a hint. Remember that 100 equals 10 tens. Pause the video and turn and talk to a partner. If you said that we need to regroup one of the 700s in 728 for 10 tens, you are right. We can trade one of the 700s for 10 tens. Then we can add the 10 tens to the 2 tens that are already there in 728. Now let's record what we just did. We draw a line through the 7 in the hundreds place in 728 and write a 6 above the 7. This shows we took 100 away from 700s so we could trade it for 10 tens. That left us with 600s in 728. Now we draw a line through the 2 in the tens place. Then we write a 12 there. The 12 represents the 10 tens we got from the 100 plus the 2 tens that were already there. Now we have enough tens to subtract 6 tens from 12 tens. So we remove 6 tens blocks from the 12 tens blocks using a red line in the model. And 12 tens minus 6 tens equals 6 tens. Pause the video and count the tens blocks we have left in the model. So we record a 6 at the bottom of the tens column in the subtraction problem. Now we need to subtract the digits in the hundreds place in our subtraction problem. Do we need to regroup in the hundreds place? Pause the video and turn and talk to a partner. If you said no, we do not need to regroup the hundreds, you are right on target. That is because 600s is greater than 500s, and we can subtract 6 things minus 5 things. So, let's first remove 500s blocks from the 600s blocks in our model with a red line. And 600s minus 500s equals 100. So we record a 1 at the bottom of the hundreds column in the subtraction problem. So 728 minus 564 equals 164. Notice in this subtraction problem we had to regroup or trade only one time from the hundreds to the tens. Now in the next problem we do, we will have to regroup 2 times in 2 place values. And we will use 4-digit numbers instead of 3-digit. Now remember, you just learned how to regroup tens to ones and hundreds to tens in some 3-digit subtraction problems. You can do the same thing even if you are subtracting 4-digit numbers like you see here. So, let's see how that works. We will start our subtraction process with the digits in the ones place, with this 4-digit number, just as we did with 3-digit numbers. Then we will subtract the digits in the tens place, then the digits in the hundreds place, then the digits in the thousands place. We always subtract in that order in case we need to regroup from a larger place value to a smaller place value. So let's get started. Notice that we represented 3,214 with 3,000s blocks, 200s blocks, 110 block, and 4 ones blocks. Look at the digits in the ones place in both numbers in the subtraction problem. Ask yourself, can we subtract 6 ones from 4 ones in the ones place? If you said no, we cannot do that, you are absolutely on target. Ask yourself, how can we get more ones to increase the 4 ones in 3,214? Pause the video and turn and talk to a partner. If you said we can regroup or trade one of the 10s for 10 ones and add the 10 ones to the 4 ones in 3,214, you are correct. To show this, we will first trade one 10 block for 10 ones blocks in our model. How many 10s blocks do we have now? Yes, 0 10s. How many ones blocks do we have now? Yes, 14 ones. Let's record this in our subtraction problem. The 110 in 3,214 becomes a 0 because we traded that 10 to get 10 ones in our model. The 4 ones in 3,214 become 14 ones because we added the 10 ones to the 4 ones that we already had in our model. Look at the 14 and the 6 in the ones place in the subtraction problem. Can we subtract our digits in the ones place now? If you said yes, we can, you are quite right. To model this, we will remove 6 ones blocks from the 14 ones blocks by drawing a red line through them. How many ones blocks are left? Pause the video and count them to find out. Correct. There are 8 ones blocks left. So 14 minus 6 is 8, and we record an 8 in the ones place below the ones column in our answer. Now look at the 0 and the 8 in the tens place in the subtraction problem. Can we subtract 8 tens from 0 tens? If you said no, you are so right. Ask yourself, how can we get more tens to subtract in the tens place? Remember, 100 equals 10 tens. Pause the video and turn and talk to a partner about this question. If you said we can trade 100 from the 200s in 3,214 for 10 tens and add the 10 tens to the 0 tens, you are correct. If we add 10 tens to the 0 tens, that will give us 10 tens in the tens place, because 10 plus 0 is 10. Let's show this with the blocks in the model. Look at the model. To regroup, we removed 100s block with a red X and traded it for 10 tens blocks. Look at our model again. That trade gives us 100 block and 10 tens blocks now. To record this, we need to change the 2 in the hundreds place in 3,214 to a 1. We also need to change the 0 in the tens place to a 10. Look at the subtraction problem. Now we can subtract 8 tens from 10 tens. Look at the model. We will cross out 8 tens blocks from our 10 tens blocks to show 10 minus 8. Pause the video and count how many tens blocks are left. Notice we now see the 2 tens blocks we had left when we subtracted 10 blocks minus 8 blocks. So we will record a 2 in the tens place, below the tens column in the answer to the subtraction problem. Next, we need to subtract the digits in the hundreds place. Do we have enough hundreds to subtract 0 hundreds from 100 in this problem? Pause the video to think about this question. Yes, we do. No regrouping needed for the hundreds place. So we take 0 hundredths blocks away from our model. We also record a 1 in the hundredths place in our answer, because 100 minus 0 hundredths equals 100. Notice we removed one of the thousands blocks. Pause the video and turn and talk to explain why we did not have to regroup again. If you said we did not regroup again because we can subtract 1,000 from 3,000s, you are correct. Look at the model. How many thousands blocks do we have left now? Of course, we have 2,000s blocks left. So 3,000s minus 1,000 equals 2,000s, and we record that 2 in the thousands column in our answer to the subtraction problem. So 3,214 minus 1,086 equals 2,128. A subtraction poem to help you with regrouping. It's time to trade for 10 more, so we group a value from next door. Then subtract and you will score. Here you see a few more subtraction poems to help you with regrouping. More on top? No need to stop. More on the floor? Go next door and get 10 more. Numbers the same? Zero's the game. Let's try some problems together. Work the problems in your journal or on notebook paper. Remember the subtraction poems for regrouping help. More on top? No need to stop. More on the floor? Go next door and get 10 more. We will check the problems when you are finished. Pause the video and work your problems now. Let's discuss problem A. We cannot subtract 8 ones from 4 ones, so we need to take a 10 from the 2 tens and trade it for 10 ones. That leaves 1 10 in the tens place. When we add the 10 ones to the 4 ones in the ones place, we get 14 ones as shown. In order to subtract 7 tens from 1 10, we need to take 100 from the 9 hundredths and trade it for 10 tens. That leaves 8 hundredths in the hundredths place and gives us 11 tens in the tens place as shown. Now all digits on the top of problem A are larger than the digits on the bottom, and we can subtract all place values to get the answer that you see. Now let's discuss problem B. We cannot subtract 6 ones from 1 1, so we need to take a 10 from the 5 tens and trade it for 10 ones. That leaves 4 tens in the tens place. When we add the 10 ones to the 1 1 in the ones place, we get 11 ones as shown. In order to subtract 8 tens from 4 tens, we need to take 100 from the 3 hundredths and trade it for 10 tens. That leaves 2 hundredths in the hundredths place and gives us 14 tens as shown. We cannot subtract 9 hundredths from 2 hundredths, so we need to take 1,000 from the 4 thousands and trade it for 10 hundredths. That leaves 3 thousands in the thousands place. When we add the 10 hundredths to the 2 hundredths, we get 12 hundredths as shown. Now all digits on the top of problem B are larger than the digits on the bottom, and we can subtract all place values to get the answer that you see. Now it's your turn to try some problems on your own. Work the problems in your journal or on notebook paper. Remember the subtraction poems help you with regrouping. More on top, no need to stop. More on the floor, go next door and get 10 more. Pause the video and begin working. Check your work with the answers you see here.
Here's a quick recap of today's lesson. Hands were hanging in their chicken pen. 11 of them suddenly jumped over the fence. How many hands remain in the pen? To figure out the difference, we use subtraction. I say 0 minus 1 can't be done, cause the top number's smaller than the bottom one. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction, I say 0 minus 1 can't be done, cause the top number's smaller than the bottom one. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction.
19 hands remain in the pad.
There are 20 bumblebees flying around me. So I yell, shoot! And two decide to leave. Now how many bumblebees are chasing me? If we regroup, we can find the difference with ease. 0 minus 2. Here's what to do, cause the 0 is smaller than the 2. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction, I say 0 minus 2. Here's what to do, cause the 0 is smaller than the 2. So we regroup a 10 into 10 ones. When the top number's smaller in subtraction.
18 bees are still chasing me.
Keep practicing. Can we help you? Logging off.